Well, welcome everyone. My name is Benjamin Nuernberger. I'm from NASA's Jet Propulsion Laboratory, and today I'm going to be telling you about how we've been using XR in the NASA mission lifecycle with a software called ProtoSpace that we've been developing. So the learning objectives for this session are as follows. First, we'd like to tell you how we're using XR to help NASA engineers design and build spacecraft. Second, what are XR's benefits and some of the open challenges as related to operational procedures, for example, using this for repair and maintenance. Third, some keys to success and how we've gotten XR used in NASA JPL. And then finally, we're going to end with the importance of some user-centered design in an application that's very near and dear to everyone right now in the pandemic. So at NASA JPL, we're in the business of daring mighty things. And as you see here, we've landed 3 generations of Mars rovers on the red planet. And most recently this year, you could see the Perseverance rover and the Mars Ingenuity helicopter. And I like this view because it has a nice animation of the mass cam rotating back and forth, looking at the helicopter and looking at us. And of course, NASA doesn't just work on Mars rovers. We have various other missions, Earth orbiting satellites such as NISAR in the top left. On the top right, we have the Psyche mission that will be exploring an asteroid. In the bottom left, we have the Europa Clipper mission going to one of the moons of Jupiter. And in the bottom right, we have an Interstellar now mission. And you might be asking yourself, well, how do these missions get formulated and how do they begin? And basically, a group of people come together and ask, what is the mission? What are the scientific objectives and questions that we want to ask? In the back of the slide, you could see some very fundamental questions, such as how did the universe begin? How did galaxies begin? But not only these scientific questions, but we also need to ask, is this mission technologically feasible? Can we achieve it? And part of that, answering that question, is being able to convey in a solid way the design and the engineering behind this mission. And what we've been using at JPL is the software ProtoSpace, which is an immersive CAD visualization tool. Here you see flickering pretty fast several of the views of the Sphere X spacecraft that we showed off at one of the proposals. Here's another closer up view showing a cross section of the instrument. And what we found is that by using augmented reality, stakeholders can get their point across in a very solid, clear way to other stakeholders. They can communicate the design, the engineering, the critical design decisions that went on in developing this mission concept, explain why they made certain choices, all in the stereoscopic immersive display. And after a mission gets approved, it goes through that proposal stage, the next step is that the engineers and scientists, they need to review the designs. They need to solidify what they initially proposed. So we've also been using ProtoSpace in this stage. Here you could see a quick video of some engineers discussing the entry, descent, landing phase for the recent Mars Perseverance rover. They were discussing how and if the entry, descent, landing cables might get snagged in certain parts on the spacecraft. And eventually, after the design is solidified, we move into assembly, integration, and testing all the different subcomponents of the system. So here's an example of the NISAR spacecraft in one of our clean room high bays. This is the virtual model shown inside the ProtoSpace software. And here is an example of the engineers were interested if certain ground support equipment would be compatible in the stage of assembly and integration of the various subcomponents. And without being able to see this stereoscopically in augmented reality, it's hard to make a crucial decision whether or not you need to buy certain ground support equipment or move the spacecraft into different configurations in certain clean rooms and high bays. Here's another example where we show the Europa Clipper spacecraft to some of the engineers, and they actually took physical tools in, and they tested whether or not they were able to do a certain assembly procedure. So the point I'm trying to get across is that XR is being used at NASA JPL in the full mission lifecycle. All the way from the left here, you see pre-phase A, where you have conceptual studies and proposals of certain missions, to the middle, where you have design reviews and rehearsing procedures and actually doing the integration, doing the assembly, all the way to the operations and sustainment phases. So using XR has allowed NASA missions to solve problems more quickly and earlier in the mission lifecycle, thus reducing cost and risk. Here's a video showing overall how ProtoSpace is. Again, it's an immersive 3D CAD visualization tool that you can see in augmented reality. These are screen captures shot through the Microsoft HoloLens device. And this allows the scientists and engineers to interact with these 3D CAD models in various ways. And the basic way it works is that we take these CAD models, users upload them to our server, and then they semi-interactively edit them or focus on certain areas of the model so that they can then be rendered in real time on these headsets. And it's really cool to see it being used in a collaborative way by engineers and scientists, making critical design decisions, working in clean rooms with them. And once you put the headset on, there's various tools that you can use. Here you can see a move tool to move along certain axes. You can rotate the CAD model. You can add cross-section cut planes. You can scale up the model, as well as do some simple animations. And again, the overview of our software is as follows. Users upload a CAD model to the server. They interactively process that model on the server, and then you could view it on the web or in augmented reality. Here's a couple more screenshots. This is with the SWAT mission, which is a collaboration with CNES and several other agencies. This is showing the virtual model, part of it, half of it on the bottom, and then the physical one on top. And here's an example of the NISAR spacecraft in one of our high bays with the huge radar antenna going into the viewing gallery. So these are kind of some examples of how we're using it, this technology, on a regular basis. But I'd like to make a pivot now in my talk to talk a little bit more about step-by-step procedural instructions, which is something also that we've been looking into, as you can see on the bottom of these examples. And before I get into that, I'd like to take one quick step back and ask, why do these technologies work? And basically what you could say is that there's an informational space and there's a physical space where you want to be doing physical procedures, but what exists is a cognitive distance between the two. And what we've seen is that by using mixed reality, we can bridge the gap between these two, reduce cognitive load on the user, and make better decisions, reduce costs, reduce risk. So what we were able to do a couple of years ago was do a controlled user experiment on a mock-up of a really cool science instrument called the Cold Atom Lab. The Cold Atom Lab is currently on the International Space Station, and we were able to do a comparison between using traditional paper procedures just for a very simple task of mating and demating cables from this instrument, and compare that to an augmented reality version of this procedure. So here's the what the augmented reality version looked like. You can see the users can be guided towards specific ports on this instrument with a virtual checklist in the center of the field of view. And if you notice, the user was using a simple voice command to go to the next step.
ProtoSpace next.
So there's guidance to specific ports using the CAD model, using ProtoSpace to create this kind of interactive experience. And what we found was with 20 participants, there was a average total time improvement of about 19% for this very simple task. We also found through self-reported mental workload results that there was a statistically significant difference between the mental and temporal workload demands between augmented reality and paper conditions. And you can see more of the results of this user experiment in our paper cited below, which won the Human Factors Prize a few years ago. So that was a controlled user experiment, but what we wanted to do next was explore using this in an extreme environment. So we participated in a NASA mission called the NEMO mission, which is an underwater habitat off the coast of Florida in the Florida Keys, where astronauts and scientists go to live in a habitat and do simulated International Space Station missions, including doing diving, sea walks on the floor. So what we did for this one was we had a procedure that spanned several different task areas. This is a Google Street View panorama that you can actually see on your own time. And this is what it looks like inside this Aquarius habitat. But here I'm just showing you the 4 different task areas. You can see that it's very crammed environment, a lot of different things going on. This is what's known as the wet porch, where people dive, the crew dive in and out of this habitat. So because we weren't able to physically go there to develop this procedure, we 3D printed some physical mock-ups of the different task areas so we can develop this application. Here are the augmented reality instructions. We had some location guidance. We had a floating virtual menu that followed you or flew closer to the task area. We had detailed notes with a video, animated levers, as well as specific task area attention guidance. And here is a video showing how it looks in the actual habitat. This was not actually doing the procedure. This was a couple of days before the actual mission of the crew. Users could go to the next step, either with a voice command again, or using this HoloLens air tap gesture. And here you could see the user going again between a couple people in a very crowded environment, lots of different things going on. It's a very extreme environment. Here's a photo of the crew in red. Those were the crew members. 2 astronauts and 2 scientists participated in this experiment. The overall takeaways were that they successfully completed the procedures. It showed the capability of using AR, XR in this mission setting. They mostly used voice commands for switching steps. The HoloLens tracking was pretty good, but it had trouble in this dynamic environment of the wet porch, as you see here. There's a lot of diving gear moving in and out. The physical mock-ups we used to create this were crucial in the development of the system. Also, the ability to modify the procedure in real time was crucial. It turns out that we developed the procedure according to how they told us, but when we got there a couple of days before the mission, we had to adjust it. So having that ability was crucial. And for future work, easier navigation through the procedure was something that the crew pointed out to us as being desired. And you can read more about this in our IEEE paper here. So before I go to close this out and tell you a little bit about how we participated in the pandemic, I'd like to mention a couple keys to success. One is that I think we have had an amazing team the past several years. We've been able to seize opportunities. We've had good quality assurance on our product. Good user interface, user experience design is important with these novel technologies. It's important in any technology, in any application, but especially in these newer mediums, it's very key. Also, our agile methodology was important, being able to pivot whenever certain opportunities arose. And of course, our many engaged customers help us develop this product as well. In terms of future directions, we really want to scale this up and make it more self-service, expanding the use cases. Again, this procedure step-by-step type of interface is something a little more experimental. and it requires a little more involved authoring. So authoring, making the authoring easier of these experiences is something that's really important. And finally, I'd like to touch on how ProtoSpace was used to develop the vital ventilator project at NASA JPL. This was a project that about a year ago, or a little over a year ago, at the start of the pandemic, a group of engineers and scientists at JPL realized that they could put their heads together, and in a little over 30 days, I think, they put together a design of a ventilator targeted specifically towards COVID-19 patients. And I'll show a brief video and talk a little more.
We are designing an easy and rapidly mass manufacturable ventilator device, and it is a crazy project.
This crisis is unprecedented in our lives and requires precedented action.
In the sake of time, I won't show the rest of that video. You can look it up on your own time. But our role in this project was to create interactive assembly instructions and operation instructions. Here you could see the interactive assembly instructions using ProtoSpace to build these out, along with some videos as well. And then here you see the interactive operation instructions. And the key thing I want to point out here is that we interviewed the doctors and nurses and realized that they don't need a full-blown augmented reality solution here, but they really just need a quick user guide. And that's the point I want to make at the end here, which is that in designing these experiences, we always have to be user-centered, find out what the user needs, and design our experiences for the user. And with that, I will say thank you and open it up for any questions you might have. Thank you.